To this point, you have learned that the ratios between the lengths of the sides and the measures of the angles of right triangles are cataloged in the trigonometric ratios. You have also learned that angles can be measured in both degrees and radians, and angles with different measurements can be coterminal, meaning they rest in the same position. Now, we will combine these concepts in our study of the unit circle. One of the purposes of the unit circle is to find the values of trigonometric ratios without using a calculator. Now, finding trig ratios of any angle measure is easy with a calculator. You can just enter it into the calculator and it will give you a decimal equivalent. There are several trig ratios that can be found without a calculator because they have exact values. They won't be those decimals that go on for 10 decimal places. Some of the most commonly used trig ratios are based on the angle measures in special right triangles. And they're back. Special right triangles. You remember these, right? The 30, 60, 90 and the 45, 45, 90 triangles. These triangles allowed us to solve for missing side lengths given only one side of the triangle. Now we will apply these triangles into our angles in standard position. So here's a 30-degree angle in standard position. You'll notice the initial side along the x-axis and the terminal side up here. I'm going to make this angle into a right triangle by extending this line here and make it a 90-degree angle with the base. Great. I'm going to give the hypotenuse a value of 1 just to keep it simple. Oh, but wait a minute. Isn't this a special right triangle? It is. We have a 30, 60, 90 special right triangle. We know the measure of the hypotenuse is 1, so we can figure out the lengths of the other two sides. So the 1 corresponds with the 2y side of our special right triangle. So we can make a simple equation, 2y equals 1. And we know that the smallest side over here is y, and the middle length side is y times the square root of 3. So we can solve for what the value of y is by using the hypotenuse. We can plug in that value to the middle and the shortest side. So if 2y equals 1, that means that y equals 1/2. So this side over here will equal 1/2. And then y times the square root of 3 will be 1/2 times the square root of 3, which is the square root of 3 over 2. All right, let's clean this up. That looks better. Since we have all the sides and angles, we could write out the trig ratios for the 30-degree angle now. First, we'll label our triangle. Our angle is 30 degrees, and the opposite side is over here, and that is 1/2. The hypotenuse is opposite the right angle, and the adjacent side will be down here. Now remember, the 3 major trig ratios are sine, cosine, and tangent, and we have the mnemonic device, SOH, CAH, TOA, to help us remember how we arrived at each of the ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So here we can first solve for the sine of 30, and it's opposite over hypotenuse. The opposite side is 1/2, and the hypotenuse is 1. So it'll be 1/2 over 1, compound fractions. But that's okay, this is an easy one. 1/2 over 1 is just 1/2. All right, cosine of 30 would be the adjacent over the hypotenuse, so that would be square root of 3 over 2 over 1. Oh, anything over 1 is itself, so this one's okay as well. Square root of 3 over 2. Now, tangent, we'll have to see about this one. Tangent of 30 will be opposite 1/2 over the adjacent, square root of 3 over 2. Oh man, we have to divide fractions. 1/2, that's okay. Dividing fractions is okay. 1/2 divided by the square root of 3 over 2 is like 1/2 times the reciprocal, 2 over the square root of 3. Now these two will cancel out. And we end up with 1 over the square root of 3. So all we have to do is rationalize that denominator, take the unrational denominator and multiply it by the top and the bottom, and we get our final answer. Or I'll put it over here. Square root of 3, because square root of 3 times 1 is square root of 3, and then the square root of 3 times the square root of 3 is 3. Square root of 3 over 3. Very messy. Let's clean it up. Ta-da! Here we are. Now, I want you to notice that the sine, the cosine, and the tangent are all exact values. They are not decimals. They are not rounded numbers in any way. The sine of 30 degrees is exactly 1/2. The cosine of 30 degrees is exactly the square root of 3 over 2, and the tangent of 30 degrees is the square root of 3 over 3. Those are much more accurate answers than the decimals that you usually get with calculators. Now let's turn that last triangle on its side and solve for this 30, 60, 90 triangle with the 60-degree angle in standard position. You'll notice our hypotenuse is still 1, so we can figure out the other two sides. And the smallest side is always half of the longest side, so this will be 1/2. And the middle length side is the square root of 3 times the smallest side. So square root of 3 times 1/2 is square root of 3 over 2. Now let's find the sine, cosine, and tangent of the 60-degree angle. But first, let's label our diagram. The square root of 3 over 2 is now the opposite side, and the 1/2 is the adjacent side, and the 1 is still the hypotenuse. And we can remember our SOHCAHTOA, and that will help us make our ratios. So the sine is opposite over hypotenuse. So the sine of 60 is square root of 3 over 2 over 1. Once again, anything over 1 is itself. So the sine of 60 is just the square root of 3 over 2. The cosine of 60 is adjacent over hypotenuse. The adjacent side is 1/2. The hypotenuse is 1. So that's just 1/2. And the tangent of 60, here we go. All right, it's going to be the opposite side, the square root of 3 over 2 divided by the adjacent side, 1/2. Okay, let's do it over here again. Square root of 3 over 2. And dividing those, I'm going to multiply by the reciprocal, times 2 over 1. Oh, this is much simpler. Those will cancel out. The square root of 3 over 1 reduces to just the square root of 3. Excellent. Let's clean it up a little bit. All clean now. Perfect. You know what, though? There is another special right triangle, a 45, 45, 90 special right triangle. Let's take a look at that one. All right, so if we put a 45-degree angle in standard position and we make the hypotenuse 1 again, let's figure out the other sides. So the hypotenuse is in the part where we considered it to be x times the square root of 2 in our standard diagram. I'm going to set those equal to each other. 1 equals x times the square root of 2. And I know that both of these sides are x. So if I can solve this equation up here for x, I can just put that value in for the other two sides of the triangle. And since it's isosceles, we know that they're going to be the same as each other. So I'm going to divide both sides by the square root of 2. And I get x, those cancel. X equals 1 over the square root of 2. All right, we have to rationalize that. So square root of 2 over the square root of 2. So x will equal square root of 2 times 1, which is the square root of 2, over 2. Square root of 2 times square root of 2 is 2. Okay, and that's what each of the other sides are. This is going to be the square root of 2 over 2, and this is going to be the square root of 2 over 2. Not bad. So if if we're going to look for the sine, cosine, and tangent of this from that 45-degree angle, this is the opposite side. This is the adjacent side. And this is the hypotenuse. So our sine will be opposite over hypotenuse. So the square root of 2 over 2 over 1. We'll just call that the square root of 2 over 2 because the 1 will cancel out. And our cosine will be the same because our adjacent has the same measurement. Now the tangent will be the opposite divided by the adjacent. Well, the square root of 2 over 2 over the square root of 2 over 2, it's the same thing over itself. That's just going to be 1. Not bad. Let's clean it up. Okay, let's put the ratios that we found in all 3 of those angles into one chart. Oh, wow. Look at this. So there's a lot to take in here. First off, let's look at the diagram. We have a 30-degree line, our 30-degree angle, our 45-degree angle, and our 60-degree angle. And notice they all end on this circle. That's because it's a unit circle, and that line goes through a circle with a radius of 1. So that's why all our hypotenuses were 1, because they all connect to that same line. Now, when we were finding the 30-degree angle, for example, we made our triangle look like this, and it had a y value of 1/2, an x value of the square root of 3 over 2, and then the hypotenuse was the 1. And all of these values show up in our chart. The y value 1/2 is here in our chart under 30 degrees, and our x value of square root of 3 over 2 is here for the cosine. And then remember, we divided the 1/2 divided by the square root of 3 over 2. And once we finished simplifying that became our tangent of square root of 3 over 3. So looking at the chart itself, do you notice anything about the numbers? The sine of 30 is the same as the cosine of 60. Likewise, the sine of 60 is the same as the cosine of 30. This is because they based on the same triangle, just using a different acute angle to find each ratio. The 45-45-90 triangle has the same sine and cosine because it's isosceles, so the opposite and adjacent angles are the same. Look at the coordinates of our endpoints in the graph. Do you notice anything about their values and the values of the trig functions? There it is. The sine of any of the angles has the same value as the y coordinate of the endpoint. 30 degrees had a y coordinate of 1/2, and that was the sine of 30 degrees. 45 degrees had a y coordinate of square root of 2 over 2, and that's what the sine is. And 60 degrees had a y coordinate of square root of 3 over 2, and that's the same here. The cosine of all the angles has the same value as the x coordinate of the endpoint. So the square root of 3 over 2 reappears right here in the cosine of 30. Square root of 2 over 2, that's the cosine of 45. And the x value 1/2 is the cosine of 60 degrees. So the sine of the angle is the y coordinate of the endpoint, and the cosine of the angle is the x coordinate of the endpoint. Do you notice anything about the tangent, though? It's a little hard to see, but the tangent is always the value of the y-coordinate divided by the value of the x-coordinate. This is true for all the angles formed in the unit circle. It also allows us to expand what would be impossible to find out just by using right triangles. For example, we can find the sine, cosine, and tangent of 0 degrees and 90 degrees just using the sine of the angle is the y value of the endpoint, the cosine of the angle is the x value of the endpoint, and the tangent of the angle is the y value divided by the x value. So for 0 degrees using this, the sine of 0 degrees is the y value of the endpoint. So that's 0. So the sine of 0 degrees is 0. The cosine is the x value of the endpoint 1, so the cosine of 0 degrees is 1, and the tangent is the x value, the y value divided by the x value. 0 divided by 1 is 0. Now for 90 degrees, the sine is the y value of the endpoint, so that's 1. You can see 1 over there. The x value of the endpoint 0 is the cosine, and the tangent is undefined. That's because it will be 1 over 0. 1 divided by 0, you can't divide anything by 0. It leaves you with an undefined answer. Let's expand this unit circle out into all 4 quadrants. So far, we've only dealt with quadrant number 1, or I, in Greek letters. Let's move on to quadrant 2, 3, and 4. It's going to be great. I know it. Holy moly. This is impressive. All right, let's get into the unit circle in all of its glory. A unit circle is a circle with a radius of 1, and it is used to determine trigonometric ratios for several commonly used angles. The coordinates of one of the endpoints of these angles will tell you the value of the sine, cosine, and tangent ratios for each of these angles. Now, with one simple diagram, you can find the trig ratios of the most commonly used angles without the use of a calculator. Since the solutions found using the unit circle are exact, you will even have more accurate answers than you can often get by using a calculator and rounded values. Since we can only determine trig ratios of right triangles, a reference angle must be used to determine the trig functions in quadrants 2, 3, and 4. In the diagram, we see a 120-degree angle would fall in quadrant 2. To find the value of its trig ratios, we will need to use a reference angle. The reference angle is an angle being sandwiched by the terminal side and the x-axis. It must be less than 90 degrees and always positive. Here you can see our reference angle will measure 60 degrees. Making the reference angle into a right triangle will involve creating a perpendicular segment from the endpoint to the x-axis. Using our endpoint, we can place our side lengths on the triangle. Notice the adjacent side is negative. This is because the side length is found on the negative x-axis. So let's find the trig ratios for 120 degrees. You will notice that the sine of 120 degrees is still the y-coordinate of the endpoint, and the cosine of 120 degrees is still the x-coordinate of the endpoint. The tangent of 120 degrees is the y-coordinate of the endpoint divided by the x-coordinate of the endpoint. So let's fill these out. So the y-coordinate of our endpoint is still the opposite side from our reference angle, and that will be the square root of 3 over 2. The x value of our endpoint should be our cosine of 120, and that is also the adjacent side. It is negative 1 over 2. And finally, the tangent of 120 is y over x, or the square root of 3 over 2 divided by negative 1/2. So we're going to have to do a little bit of math for that. Square root of 3 over 2 divided by negative 1 over 2. And I'll write that as multiplication. So I'm going to multiply by the reciprocal. Okay, so these two will reduce to 1, and we're left with the square root of 3 over negative 1, which can be written as negative square root of 3. I want you to notice that in quadrant 2, the sine was a positive value, while the cosine and the tangent were negative values. This is going to hold true always in the second quadrant. The sines will always be positive. The cosines and tangents will always be negative. This is because all of the y values are positive in this quadrant and all of the x values are negative in quadrant 2. The tangent's negative because one of the two values is negative, the y value. So that fraction is always going to be negative. Let's fill out a chart for the rest of quadrant 2 using our beautiful unit circle. Notice all these angles will have a reference angle of 30, 45, 60, 0, or 90 degrees. So let's start off with 135 degrees, or 3 pi over 4 radians. Remember, the sine is our y value, so our y value is going to be square root of 2 over 2. Our cosine is going to be our x value, so it will be negative square root of 2 over 2. And our tangent will be y over x. Since they are the same numbers, they reduce to 1, but one of them is negative, so our tangent will be negative 1. Okay, 150 degrees, or 5 pi over 6 radians. The sine is going to be the y value, which is 1/2. You can see right here, 1/2. The cosine is going to be the x value of that endpoint, so negative square root of 3 over 2. Now the tangent will be the y value, 1/2, over the x value, negative square root of 3 over 2. And we can rewrite this as a multiplication problem, 1/2 times, and then the reciprocal, 2 over negative square root of 3. That gives us, those cancel, and that gives us 1 over negative square root of 3, which we have to rationalize. So we get the square root of 3 over 3, and there was a negative in the bottom. I'll just move it up to the numerator. Negative square root of 3 over 3. For our 90-degree angle, we already did this. The x value, the y value is 1, so that's the sine. The x value is 0, that's the cosine. And then the tangent will be 1 over 0, which is undefined. And for 180 degrees, or pi radians, the y value is 0, the x value is negative 1. And so our tangent will be 0 over negative 1, which is 0. Once again, here are the sine, cosine, and tangent ratios for 90 degrees, 120 degrees, 135 degrees, 150 degrees, and 180 degrees, or their equivalent radian measures. Let's move on to quadrant 3. So in this quadrant, our reference angle for 210 degrees, for example, would be this angle right here, which would be 30 degrees. And to make our triangle, we would connect that up to the x-axis this way and make it a right angle. And now we can use our endpoint. We can distribute our endpoint to be negative 1/2 would be the y value, and negative square root of 3 over 2 would be the x value. And remember, it's a unit circle, so our hypotenuse is always 1. So this is how we can build all of our trig ratios based on that triangle that we made there. And then we can do the same thing for 45 and for 60 degree reference angles, or 225 degrees and 240 degrees. So let's start off with 210 degrees. All right, the sine is going to be the y value of the endpoint. So the y value is negative 1/2, or in our diagram, it's the opposite side of the 30 degrees. The cosine will be the x value of the endpoint, negative square root of 3 over 2. And the tangent will be the y value divided by the x value. We've already done this several times, so I'm going to just write it in as the square root of 3 over 3. But notice it's positive. The sine and the cosine were both negative. So a negative divided by a negative gives you a positive answer. All the tangents in this quadrant 3 are going to be positive because it's going to be the division of two negative numbers, because in quadrant 3, all the x values are negative and all the y values are negative. All right, let's move on to 5 pi over 4 radians, or 225 degrees. The sine will be negative square root of 2 over 2. The cosine will be the same, negative square root of 2 over 2. Remember, this one's based off a 45-degree reference angle, and that's why the sine and cosine are the same. And then the tangent, it's the same thing over itself. It will be 1. So 240 degrees, or 4 pi over 3 radians. Our sine will be the y value, so that's negative square root of 3 over 2. Cosine will be the x value, so that's negative 1/2. And a negative divided by a negative is a positive, and the square root of 3 over 1 is just the square root of 3. And 270 degrees, or 3 pi over 2 radians, or 3/4 of the way around the circle, as I like to look at it. The endpoint for that is 0, 1. So the y value is negative 1. The x value is 0. And negative 1 divided by 0, the tangent of that, would be undefined. Much cleaner this way. Okay, we have one quadrant left to go. Let's get after it. Quadrant 4, and all is well. Here, the reference angles will travel up the x-axis. So the reference angle for 330 degrees would go this way, form a right angle here. This would be a 30-degree reference angle, and we would solve it using that logic. So for 300 degrees, or 5 pi over 3 radians, our y value is negative square root of 3 over 2. Our x value is 1/2. And if you divide those two, the 2's will drop out. You'll end up with negative square root of 3. For 315 degrees, our reference angle would be 45 degrees. Once again, that is the isosceles one. So our y value will be negative square root of 2 over 2. Our x value is the square root of 2 over 2. And our tangent will be, since one of them is negative, negative 1. And in the 330 degree angle, which has a reference angle of 30 degrees, our y value is negative 1/2. Our x value is the square root of 3 over 2. And our tangent will be negative square root of 3 over 3. Now, 360 degrees is a coterminal angle with 0 degrees. So we'll have the same values as we had when we looked at 0 degrees. The sine, or the y value at 1, 0 is 0. The x value at that point is 1. And then 0 divided by 1 is 0. So 360 degrees on, we'll have a coterminal angle that's somewhere else on the unit circle. And we want to look at what's positive and what's negative. All of our sine values are negative because all of our y values are negative, and that's what sine is, the y value. The cosines are all positive because all of our x values are positive in quadrant 4. And the tangent are negative because if one or the other is negative, then the tangent's always going to be negative. Now, you might be thinking, I know there's more than just sine, cosine, and tangent for trig functions. There's also, I don't know, cosecant, secant, cotangent. Do they have values on the unit circle? Let's take a look. And yes, of course it's true. Cosecant, secant, cotangent do work on the unit circle as well. Here we have the ratio explanations for each of the six trig ratios. And as we saw already, the opposite side was always the y-coordinate, and the adjacent side was always the x-coordinate of the endpoint. Since it is the unit circle, and our unit is 1, all of the hypotenuses were 1. So we can fill out what formulas we could use to find cosecant, secant, and cotangent by substituting x wherever we see adjacent, y wherever we see opposite, and the number 1 wherever we see the hypotenuse. Let's do it. Remember, cosecant, secant, and cotangent are the reciprocals of sine, cosine, and tangent, so they have a slightly different formula for finding the values on the unit circle. but we can see that the sine of theta is y over 1, which is just y. The cosine of theta is x over 1, which is just x. And the tangent of theta is y over x. But now we have the cosecant of theta is 1 over y. So we just take the y endpoint and put it in a fraction underneath 1. And we'll probably have to do some sort of a algebraic rationalization, but we will get the cosecant. 1 over x is the secant. Same thing with x. And then x over y is the cotangent. It's the tangent, just the reciprocal. So that one actually might be pretty easy. All right. Let's take a look at the values of these ratio in the first quadrant. Here we are back at our old friend quadrant 1. And you notice that we have new definitions for what cosecant, secant, and cotangent are compared to what sine, cosine, and tangent were. Cosecant of theta is 1 over the y. So let's start with the 30-degree angle. 1 over y, the y value at 30 degrees is 1/2. 1 over 1/2 is 2. The secant of 30 degrees will be the x value, so that would be 1 over the square root of 3 over 2, which now we have to do the reciprocal of that. That equals 2 over the square root of 3, and then rationalizing our denominator, square root of 3, square root of 3, we get 2 times the square root of 3 over 3. Now the cotangent is the x value of the endpoint over the y value of the endpoint. So we will have the square root of 3 over 2 over 1/2. So I'm just going to go right into the multiplying by the reciprocal. Those will cancel, and we're left with just the square root of 3. The 45-degree or pi over 4 angle, the cosecant is 1 over y. So 1 over the square root of 2 over 2. That will make this lower denominator up into the numerator. It's 2 over the square root of 2. Well, now we get to rationalize. Square root of 2 or square root of 2. Okay, so we have 2 times the square root of 2 over 2. We'll cancel that, and we'll just have the square root of 2. Oh, that was easy. It's just 2. It's just the square root of 2, I should say. And the one good thing about that is the secant and the cosecant will be the same because it is isosceles. And the square root of 2 divided by the square root of 2 is still 1. So that works for 45. And 60 degrees, or pi over 3 radians, it's actually going to be the flipped version of the secant and the cosecant. This will be 2 times the square root of 3 over 3. This will be 2. Cotangent will be x over y. Now our x over here is 1/2, and that's going to be over the square root of 3 over 2. So I will write that over here. 1/2 divided by the square root of 3 over 2. So I'll just go right into multiplying by the reciprocal. 2 over the square root of 3. Those cancel. We have 1 over the square root of 3, which we've seen before is the square root of 3 over 3. Whew. All right, that was the hard part. The rest is easy. 0. What is the cosecant of 0 degrees or 0 radians? It's 1 over 0, undefined. The secant is 1 over x. That'll be 1 over 1, which is 1. And the cotangent will be the 1 divided by undefined, which will also be undefined. Okay, 90 degrees now. 1 divided by the y value of the endpoint, which is 1. So 1 divided by 1 is 1. 1 divided by 0 is undefined. And x over y, 0 over 1 is 0. Excellent. Let's look at it more cleaned up. So there you have it, folks. That's how you use the unit circle to quickly find sine, cosine, tangent, cosecant, secant, and cotangent values without using a calculator. I would like to thank you all for watching this video. Make sure you subscribe to my channel for more amazing math content and smash that like button. I could really use the boost right now. Please.